a specific before voting the EU order. As you can see, in this case, it is completely tacit knowledge, because I can say a thing and then vote another thing. Okay, data. Okay, now the structural machine learning. The previous part described more or in fast way the tools, but they can be used in different way. The first way is the data fusion. The data fusion is the process of parameter estimate from data originated by multiple sources. For instance, we have different sensors at the environmental level, water, air, other. I can, on a specific area, I can monitor in a specific time using all the sensors simultaneously, and I can record the data from each sensor. Now, what is the problem? The problem is to find the statistical relation about the data coming from different methods, different sensors. The data fusion is the possibility to make statistical inference from different data sources. The basic approach are that are embedded in data fusion are data association, is to extract the relation among the input data sources. The state estimation, for instance, the example is the position of an airplane, but otherwise in an environmental point of view is the point estimate of pollutional level, and the prediction is found on and the state estimation is in fact the predictive system. This is the machine learning. The third, the decision fusion. Normally this system offers to the operator a set of alternatives, and the decision part, the rules and then obtained by the second step has been broadcasted to the user, and the user select what, according to his experience, what is the better action to activate. Thanks. Some application of data flow you can see here: analysis of data, capture environmental sensor, protein structure prediction, because in this case we have difference. We assembled the output from high throughput crystallography. High throughput crystallography is an approach that allows to obtain a crystallographic structure using droplets of crystals. Then after you can assemble an high-order structure. It's a very expensive system. I guess there are only 2 or 3 centers. One is in the UK that use this approach, because as you can imagine, having a crystallography that can work on a chip is very, very expensive. Disease prediction is fact, because of disease prediction having several sources that can be obtained from epidemiological database, clinical database, or what you want. The urban planning, why I put urban planning? Because in terms of exposure, urban environment tends to become more important. The expansion of many towns in India, China, create a specific environmental context in urbans. And the last, disease and pollution. This is you can find in the paper, and they use different approach to, for instance, there are some studies that link the air pollution and tuberculosis, and incidence on tuberculosis, because the pollution has an impact on immunological systems and increase the susceptibilities to some infectious disease such as tuberculosis. Thanks. Okay, this is an example from this paper that show you in which way the data fusion has operated into biomedical context. You can see, we come back, it's a strange data fusion because SIMP is a network in this case, and the things are strongly related, and the hugs connect the relation, as in the case yesterday about the ontology. Also here I do not know the meaning of I guess it's the length of the arc or the correlation between the nodes, and it was interesting because it's not a modular and parallel integration, but it's a network integration. The main feature of this figure is that for exposome we need a network integration, or in other way, a graph integrations. Then you can see the difference. It's interesting to note that disease is connected with ontology, okay, and with genes, the dotted line, and how the different different database and different data are managed and analyzed depends by the tools that are embedded in the systems. I'm sorry, but I am using it only to give an idea of biomedical information there. I do not know if they use machine learning or if they use statistics or what they have. You can find the paper on bioinformatics 2 years ago, and in any case you can please. Okay, and now we come back on the basis of the process. The problem is how to find a concept or how to find the meaning of specific object. It's very complicated because an abstract concept requires the convergence of syntactic logic and mathematics on the same goal. And this is an abstract concept. The methodological approach for required to extract the basic knowledge to required for the concept formation is information retrieval for the methodological approach, data acquisition, data analysis, concept extraction, hypothesis generation, and theory formulation. That is machine learning, in fact. On the other side, observational approach, this can be automated. The observational approach are the measure, the recognition, and the experiment. And this define the concrete concept. What the experience of a scientist or as formulate, because here we can have physical data, the capability to recognize some results by expertise, experimental, and interpretation. This is interpretation in this case is not automatic. Is what in the diagnostic point of view, we have all the data, but the last decision is the clinicians. In the case of exposome, the interpretation, the decision is having all the possible information mined in the best way is given to the political level or to the technical manager that must decide an action for a specific situation. Then the problem is the logic and mathematics and syntactic, that is linguistic in some way, that must cooperate in the same to formalize the concept. As I said, the DNA is the basic molecule, is the genetic information element. It's clear, it's a concept, roughly speaking, but is a written concept, is a communicable concept. For a machine, for a computer, I must to formalize in which way I can represent this concept. A first logic order or other systems are built, and I must to have formal methods from logic and mathematics to code the concept in a way that the machine can read and can process or can create. This professor that now is died is Joseph Gauguin, is mathematics and logics, that attempted to fuse together different elements that are required for concept formations. The database semantics, as you can imagine, is the semantic level of data mining. This conceptual space is a geometrical representation of that knowledge on a hyperspace. The formal concept analysis is roughly speaking, is the coding of concept in string with logical formalism or logical operators in order that can be represented. Information flow is in fact the element that bring new elements for concept elimination to generate a concept. And information flow work is, let me say, is the content in which a system addressed to generate concept is working. The concept is a very complex problem. Please, thanks. Okay, the problem, the concept required is possible to organize the basic knowledge into categories. The categorization can be done, is the process in which the objects are recognized as a group and understood, conceptualized. Then the groups that you obtain from a machine learning supervised or not represent contains a prototype of the concept and its variations. In the supervised, the rule abstraction from labeled samples, that is classical supervised systems. I can classify with a neural network because I have a good training set. I have trained my system with the training set and check, and the network has, in a statistical way, mapped the logical conjunction, logical links between the elements of my data. Then the classification, class A, class B, is related to the knowledge fragment and the concepts that are stored in a transparent way in the network. The other is unsupervised. Rule abstraction is performed by analyzing the unlabeled data and finding the hidden relation inside the data. The first, the supervised, as you can imagine, is more easy to use and more easy to visualize and to apply. The second, believe me, to extract that knowledge from an unsupervised system and to visualize it is quite difficult because it requires an additional statistical post-processing to analyze the degree of dependency among the features that we have analyzed. Thanks. Okay, this is the language. There is in order the concepts are related to the semantics. Don't forget the concept of semantic web and semantic analysis, because I would like to focus on this aspect, because Exposome is not only microarray. Is unfortunately not all the data are value from experimental data. Depends by a lot of additional situations, such as the language that is extensional semantics that describe the word, the language, the truth of the language allows to find the possible word, and then this intentional semantics is the strength of the concept. At the end, language and conceptual structure, the cognitive semantic, combine the language and the conceptual structure. In terms of Exposome, what is the meaning? The meaning of this slide said that we have unstructured information that give us information about pollution on a specific area. Description given by report, by census, but what you want. In this case, the language describe a word. Even if you have table data that are supplementary data, but it's the description that give to you what is the situation. If I said there is too much cadmium in the water and give you after the table of my experiment, I can use the experiment for creating a training set. But it's the text of the paper, the text of the report that give the meaning of or the relevance of the thing. How many, when you search a paper for an experiment for what you want, you read the abstract. The abstract is the meaning of the not always the results agree with the abstract, but essentially is the language that describe in this case the word of this experiment, the word of this case. If obviously if the language is true, if you find that correspond the abstract with the content, you can go to evaluate how strong is the concept. For instance, BCR2 is a gene involved in breast cancer. It's true, the literature confirm, and you can analyze the strength and how this semantic structure is strength, and how many variations there can be. The last is the complete system, cognitive semantics, that in other words is the aim of artificial intelligence. You can see here more or less what artificial intelligence won't do. Please. Okay, what is a concept? A concept is an abstraction or a mental symbol. A concept is the top level of knowledge discovery. Typically associated with a corresponding representation in a language. Then it's not a set of objects or a category, class, and their relationship. There is feature, and this feature must be correlated by logical operator and or not what you want. Or types of concept are objective concepts that represent the real context in which the observer operates. In which obviously I am here, the concept of computer is quite clear in this context, or the concept of cancer is clear in a biomedical field and other. Subjective concept that represent a logical structure elaborated by the observer. Well, what happens? I am an observer. I make my experiments. I formulate my hypothesis. I produce a paper according to my hypothesis. It's not true. My paper is published, but this hypothesis is not only my hypothesis. It's not confirmed by at the moment by other people. Then I publish only my hypothesis. Otherwise, that I do not know. Imagine what you want. What experiment do you want? There are the objective is the smoke originate cancer. Okay, but if I publish a paper, the smoke does not originate cancer. Is my hypothesis, but probably is mistaken. What is the effect? The effect that on the machine learning is that how many subject, what is the fraction of objective concept, let me say that is the good part of the training set, and what is the fraction of the subjective concept, or that could be a noise factor in the creating your data set. Because I select all cancer, talking about the smoke, I can I create a data set of 1,000 a paper, 1,000 experiments about the smoke. There is also 20 experiments that does demonstrate that the smoke is not a factor of cancer, it's not a cause of cancer. The 20 experiments in your data set have a weight, more or less 20%. This happens another way, and how to control your data set and how you optimize the fraction of good and bad data for the training. Because in this case, we can have a small bias due to subjective concept on the training, and then after on the final performance of your systems. The concept has some property that are called extent. Is the set of objects that belonging to the concept. The objects are the element that or the features at low level that originate the concept, that part of the concept, and intent is defined by the set of attributes sharing among the object belonging the concept. Then, this is important in terms of machine learning because these are the features that used to discriminate one class to another. And this is when you use a classifier, you can find the different level of the different weight of each feature used for classification. You could working on this level. When you classify, when you prepare, when you train a machine learning system, you use the extent because the object on each class, on each group. When you want to decide what are the feature, the more relevant feature, you use the intent of the concept. Okay, one way that I like very much is called conceptual clustering. It's a variant of conceptual clustering using symbolic data more or less. Instead, then it is able to classify, to organize into groups different objects, not as new number, but as a entity, as strings, as record, as what you want. And supervised concept learning generating hierarchies to explain the data is the property to establish a first row level of semantics. Row. So I would like to underline row. The application is the hypothesis generation and testing, the prediction based on group, and finding taxonomy. Why I'm talking about this thing? Because I am using similar approach to check the congruency of families of phylogenetic trees. It's also interesting for machine learning because in the phase of data cleaning, of data warehousing, having the possibility to filter out, to have a little initial level of semantic is not so bad. It can be useful for refine the other tools that can be applied subsequently. Technology discovery can be performed by a top-down, and we come back to the ontology. You here understand that one of the key points is the ontology, in which human expertise formalize the knowledge, and the other is bottom-up, that is starting from unlabeled information to knowledge creation, and creation is conceptual space. Conceptual space is represented as vectors in a Euclidean space, and you can go on, please. And the representation in this case in a vectorial form, that this approach allows to us to transform data in a machine-readable way, quality dimension feature. A conceptual space structure can investigate a sub-symbolic level. Then it's possible to apply deep learning, neural network, what you want to this representation. A conceptual space is a convex region space. Is determined by Voronoi tessellation. And the structure of conceptual space is an emergent property. It's important because the structure of conceptual space as emergent property suggests the idea that the knowledge is a dynamic process controlled by dynamical systems. Thanks. Then the change, the concept drift. But a concept not always stable. A concept can change with the time. And changing with the time can change the quality of the data that we must to have used in an exposome analysis. 10 years ago, the impact of something on the glyphosate, okay, are used by 20 years, but only now emerged glyphosate problems. Why? This emergent, the concept glyphosate is toxic. 20 years ago, you can not create this kind of concept. Now, yes. The concept drift is a definition of machine learning that define how the statistical process of a concept change during the time. Change when, if you make a training set now in the 1982 on the same thing, the performance, and now make a training set now on the same topic, probably and using the same classifier, the classifier change the performance. This change of performance, if all the computational procedures maintained, could be, and if the feature, obviously, we create two data sets with the same feature, obviously, and the difference could be related to a change of relevance of some element. And